Hey guys, so in section 3 we're going to be taking what we've learned in sections 1 and 2 and some of what we did at the end of chapter 3 and put it all together and make models for quadratic functions. So our objectives are I don't know where they went. Okay, well apparently we're going to get right started. So writing an equation of a parabola. So a parabola contains the points 0, 0, -1, -2, and 1, 6. What is the equation of this parabola in standard form? So what we're going to do with these is we're going to use each one of these points to plug into our standard form. Remember what standard form is? Y equals ax squared plus bx plus c. And we're going to do each one individually, so 0, 0, -1, -2, and then 1, 6. And we're going to form a system of equations, and we're going to solve using substitution or elimination. So hopefully you remember how to do that stuff from last week. Okay, so for my first equation, I put in 0 equals a times 0 squared plus b times 0 plus c. So that cancels and that cancels, so I get c equals 0. So that's going to be really nice. Alright, I get -2 equals a times -1 squared plus b times -1 plus c. So when I simplify that one, 1 squared is positive 1. So I get -2 equals a plus b plus c. And then for my third equation, 6 equals a times 1 squared plus b times 1 plus c. So for this one, let's see, I get 6 equals a plus b plus c. Okay, we already know that in both of these, c equals 0. So I'm just going to go ahead and take this 0, c is 0, and put it in here. So c is 0, c is 0. So now I just have a plus b equals -2, and a plus b equals 6. So I need to use my systems of equations. Alright, so I need to use elimination. Oh, I missed this -1 here, so this is a -b. So I can go ahead and just add these two equations together, and I get 4 equals 2a, because the b's cancel. Divide by 2, a equals 1. Now I need to substitute back in to find b. Let me grab a different color really quick. So 6 equals a, which is now 1, plus b, subtract 1 from both sides, b equals 5. So if I have a, b, and c, I just plug them in for my a, b, and c here. So I get y equals, a is 1, so I'm just going to write it as x squared plus, plus 5x, and then c is 0, so I'm just going to leave it like that. So here is my standard form of this parabola. Okay, hold on. I was looking at this again. I saw my math error. I apologize. 4 divided by 2 happens to be 2, not 1. That makes this 2x squared. And if I put this in, subtract 2, b becomes 4. There, that looks better. Okay, so y equals 2x squared plus 4x. See, math teachers make mistakes too. Shh, just don't tell anybody. Alright. So comparing quadratic models. Are any of you taking physics? Probably. Campers at an aerospace camp launch rockets on the last day of camp. The path of rocket 1 is modeled by this equation, -16t squared plus 150t plus 1. If you think about it, why would it be negative? Well, parabolas are upside down. For a rocket to launch, it first has to go up in the air to come back down. The path of rocket 2 is modeled by the graph at the top of page 210. So I'll go ahead and pop that picture up here. Alright, so here's the picture of rocket number 2. So they're not actually telling us what the equation is, but they're giving us a picture of it. So it wants to know which rocket flew higher. So what we're going to have to do is to find the maximum height of each rocket. So go ahead and put rocket 1 into your y equals of your calculator and just change the t to x, and then use your second calc and then your vertex or your maximum which is second calc maximum is number 4 to find your vertex. So go ahead and do that. So let me just go ahead and show you on my calculator here that I have. So I have this calculator, and when I put it into the y equals, you can see my equations there. Then when I graphed it, it kind of just looks like a line over to the side. And I don't really like that line. So what I'm going to do is I'm going to hit second, no, not second calc. I'm going to hit second, nope, just, never mind. Disregard, just hit zoom. I just want zoom. And I want to go down, all the way down to the bottom one, zoom fit. When I click on that, it's going to, there you go, kind of give me a better image of what my graph looks like. But you can tell when I go to my window, my x is still from -10 to 10, but my y is from like -3,000 to like 350. So that's why we couldn't see anything on our graph, is because our values are way off of the -10 to 10 like it normally is. Okay, so go ahead and go back to your graph, and then you're going to hit second calc. Come on. And you're going to go down to, like, that's a maximum. So we want maximum. We're going to go left bound again like we did last time. Ask for left bound, and then ask for right bound. So make sure you go to the right of the vertex. I like to move over pretty far. Okay, and then it's going to guess, calculate. There you go. And we have our maximum is 4.68 seconds, and it's 352.5 feet. So that's how big or how far up our parabola went. If you wanted to change your window so that since we know it's just positive, we could go from 0 to 10 on our x scale, and on our y scale we could start at 0 and just go to like 500. Let's graph that and see what that looks like. That looks more like our parabola that's in the book. It would give us just the positive part. Our intersection is still going to be the same thing. So let me get back into our lesson here. So we found the vertex of the one parabola. Now we need to estimate the vertex of this one that they give us in the book. So if you look, the vertex here is about 6, maybe 575. So of these two, remember that our x value is in time, but of these two, which one of them flew the highest in feet? That's our y value. Well, if our first value was 352 and our second value was 575, obviously the second rocket, this one here, is the one that flew the highest. Okay, and then also think about this one. Which rocket stayed in the air longer? So instead of looking at the x value, look at the y value. That was still rocket 2. Obviously, if it's going to fly higher, it means it's going to have to be in the air longer. Reasonable domain and range for quadratic models. For these, obviously our domain and range are going to have to be greater than 0, because we're not talking about negative height, unless you're talking about things falling into the earth. So the domain tells you your x values, your reasonable x values, and your range tells you your reasonable y values. Alright, and I want you to think about this one. Your classmate says he can write the equation of a quadratic function that passes through the points 3, 4, 5, negative 2, and 3, 0. Explain his error. So you're going to have to use a little bit of critical thinking. Remember what you know about functions, and then I want you to write down an answer, and then you're going to discuss it with your partner. And then your homework will be section 4.3 on Math Excel, and I hope you have a great night. Talk to you tomorrow.